There are basically four fundamental principles in object-oriented programming, and they are abstraction, encapsulation, inheritance, and polymorphism. So any programming language, if they follow these four principles, then they can be called as object-oriented programming language. But first, let us understand the basic terminologies in object-oriented programming, such as classes and objects, which are one of the most widely used terminologies in the object-oriented programming. An object is basically an instance of a class. In simple words, objects are representation of real-world objects like, for example, car, bike, dog, cat, etc. Classes are like blueprints or models using which objects can be created. For example, vehicle can be a class and car can be its object. Object will have attributes and methods. Attributes are nothing but data. For example, attributes of a car can be steering wheel, engine, doors, wheels, etc. Methods are nothing but the behaviors. For example, car can start, it can accelerate, and it can also stop. So these are the behaviors of car. Let's create a simple class. So let's create a simple class for vehicle. So I'll write class vehicle, and I will simply write pass. We are creating a simple class without any attributes or methods. So I am not having any, this class does not have any attributes or methods. So we are just writing pass. Okay, so let me execute this. So we have created a simple class without any attributes or methods. Now let's create a car object or instance which belongs to this vehicle class. I'll say car1 equal to vehicle and execute this. So when I print car1, you can see that it is an object, that car1 is an object of the vehicle class, or an unique instance of object of the vehicle class. Okay, now let's recreate our class with some attributes. Okay, so attributes are nothing but the features. So in the initializer, so this is how you write an initializer or the constructor. So an initializer or a constructor is the first method that gets executed when the object is created. Okay, so the initializer or also called as constructor, we can define the attributes that or the features that we want to our class. So writing self is mandatory as the first parameter, and then we can write the attributes that we need for this vehicle class. So vehicle can have number of wheels as an attribute. It can also have a type of engine as an attribute, and it can also have, for example, seating capacity, and what else? It can also have something called maximum velocity. Each vehicle can have a maximum velocity or a different maximum velocity. So these are the different attributes that we have. So when we create an object of this class, we are going to assign the attributes. So we have to write self dot number of wheels equal to number of wheels. So this line will basically assign whatever the number that you are passing to that particular object. So I'll say self dot type of engine equal to type of engine, and self dot seating capacity equal to seating capacity, and finally self dot maximum velocity equal to maximum velocity. So now we have created a class with some attributes. Now let's add something called as Getters and setters. So getters and setters are basically special type of methods in a class that can be used to access the attributes of our object. Okay, let me write a getter method. So I'll write the getter and setter method only for one of the attributes, which is number of wheels. So using this get number of wheels, if you call this method, it will simply return the number of wheels that the particular object, it will just return the number of wheels that that particular object is having. Okay, let me also define the setter. So the setter method is basically used to update the attribute. Okay, when I call set, so I'll say self and the number, the new number of wheels. So I'll say self dot number of wheels equal to number. So whatever number that we are passing, it will be updated. So let me execute this. Okay, so now let us create an object of this vehicle class with some attributes. So let me create a vehicle. For example, I'll create a car and call it as Audi, and Audi is equal to vehicle and the attributes that it has, as it has 4 number of wheels, and it has next is the type of engine, I'll say petrol. Okay, and then it has 5 seating capacity and the maximum speed, let's say it is having 200. Okay, so I'll execute this. Okay, let's try printing the number of wheels of Audi using the getter method. So I'll say Audi dot, if you say get number of wheels, it will return the number of wheels that our vehicle is having. And if you want to change or update the number of wheels that our vehicle is having, you can make use of the set number of wheels method and pass, let's say for example I'll pass 5. I'll execute, and now if I check the number of seat by using the getter method, you can see it has been updated from 4 to 5. Okay, let me just copy this. Now let me create the class again with an object, with a method. I'll write one method called move. So our vehicle will move when this method is called. So when you call this method move, I'll simply print vehicle is now moving. Okay, I'll execute this. Now let me create the object again, and then I will call the move method and see what happens. So you can say that it prints vehicle is now moving. So this is how you create a class with a constructor, some attributes. These are the getters and setters, and this is a method. So these are also called as attributes or features, and this is called methods or behavior. Okay, now let's move on to understanding abstraction and encapsulation, which is two of the main principles in object-oriented programming. Abstraction is basically the thought process of hiding unnecessary details. For example, if we take a look at the calculator, it has only numbers and operators. Internal details on how the calculations are done are hidden from calculators. Okay, and encapsulation we can call as the actual implementation of this thought process of abstraction. It tells us how we can hide unnecessary details, or also in other words encapsulate some details from the user. Let's see a simple example of how Python supports encapsulation. In programming languages such as Java or C#, we have something called access modifier keywords such as public, protected and private. These access modifier will help us to restrict access to the required attributes and methods in our class. In Python we do not have those keywords, but we can make the required attributes or methods private or protected by appending underscores to the attribute name. Let's see an example to understand this. So let me create a class here. I'll say class, my class. Okay, and now I'll write the initializer or the constructor. Okay, self. So let me define a public. By default, all the variables, okay, by default all the members in a class are public. Okay, all the members in the class will be by default public. So this is a public attribute. Okay, now if you want to make a certain attribute as protected, you have to use one underscore. Okay, now underscore b is an attribute which is a protected attribute. Okay, so this is public, this is protected, and self dot, if you use two underscores then it becomes a private, attribute or a private number. So the public attribute we can access this public attributes anywhere inside the class or outside the class. Okay, so the protected attributes, they can only be accessed within its child class. Okay, it can only be accessed within this class or within its child class. Now the private attribute cannot be used outside this class. It can only be used within this class, or it can only be accessed within this class. Okay, so let me create an object. Let me create an object of this vehicle class, object equal to my class. So I've created an object. So since A is a private attribute, it can be accessed outside the class. So this will work without any problem because this attribute is a public attribute. So it can be accessed outside the class as well. And adding one underscore makes it protected. Only the child classes, it should only be accessed only in its child classes, but it is just a naming convention and Python doesn't really restrict the user from using this protected attribute. So it is just like you can just access it like the public attribute, so it doesn't really restrict from using it. It's just for naming conventions. Okay, and now finally we have something called the private attributes. So these attributes cannot be used outside the class. So when you say print obj dot underscore c, okay, and when you exit this you'll get an error which basically means that you cannot access this outside the class. Okay, but Python still provides a way of accessing the private attributes outside the class as well. Okay, intentionally you can access, it just restricts the unintentional access of private attributes, but intentionally you can still access these attributes using something like, you have to write the obj dot, you have to write underscore the class name and then underscore the private attribute name. So you have to write underscore class name and then the private attribute name. So with this way you can access the private attributes as well Okay, so now let's see what inheritance is. The concept of inheritance is mainly needed to avoid repetitive coding and encourage something called as code reusability. So it is basically used to avoid repetitive coding and encourage code reusability. If we feel that certain attributes or methods can be reused in many classes, then we can put all of those attributes and methods inside one class, and this can be treated as a parent class. As any class that will inherit the attributes and methods from this parent class. So if required, they can inherit these attributes or methods from the parent class. This is just to reduce the repetitive coding of these attributes and methods. Let's see an example of how to create a parent class and inherit the attributes or methods of this parent class in another class called as the child class, or it can also be called as the derived class. So let me create a parent class here. I'll say parent class is, I'll create one parent class which is called as vehicle, and I'll create two child classes which is car and bike. So both of them are the child classes of the parent class vehicle. So I'm creating a parent class vehicle. So let me write an constructor or initializer. So let's assume we have number of wheels as the first attribute, and then let's say it has number of seats, and also let's say it has maximum speed. So these are the three attributes that this parent class is having, and I'll say self dot number of wheels equal to number of wheels, and self dot seats equal to seats, and self dot max speed equal to max speed. Okay, so we have created a class. So this is just like normal class. So there is no special keyword that you have to add to make it a parent class or something. It's just a normal class, but then if you want to, when any other class inherits this, then this becomes a parent class. Now let's declare a child class car which will inherit these attributes. So to make this as a child class, we just have to write in between the parentheses the name of the class that you want to inherit. So now this class has become the parent class and car has become a child class. Now what I do is, inside the initializer, okay, so when an initializer is called, let's have the same attributes to this as well, and then instead of simply rewriting this code, okay, since this is a child of vehicle, I can simply call the parent, constructor and just pass these attributes. So there is no need to rewrite it again. You can just reuse the attributes from your parent class. Okay. So now what I'll do is, I'll simply create an object of the car class, and I will pass number of wheels equal to 4, 5 will be the number of seats, and maximum speed, let's assume 100. And then I'll say car1 dot number of wheels, car1 dot number of wheels, it will return the number of wheels that are present in our object. In the same way, you can reuse the method or the class again, and you can create another child class called bike. Now bike is also a child of the vehicle class which has the same attributes. Okay, now let me define a bike object. So bike1 is equal to bike, and then the bike will have 2 seats, two number of wheels and 2 seats, and maximum speed, let's assume it is 100. Now when I say bike 1 dot number of wheels, it will give 2. Okay, so that was about inheritance. Now let's move on to polymorphism. When different classes have same method but implemented in a different way, we can call it as polymorphism. Okay, so let's define a parent class. For example, I'll define class animal, and let's create the initializer or the constructor self, comma, so let's assume it has only attribute the name. So when an animal is created, we have to pass the name, and self dot name is equal to name. And then I'm also assuming that all animals will talk in a different way. So that is why I'm writing a method in the parent class, and I'll simply write pass because I'm creating this as an abstract method. So any child that inherits this animal class has to implement this talk method in a different way. Okay, so let me execute this and create the class. Now let me create a child class called cat, which inherits from the animal class, and I have to override the talk method or implement the talk method in a different way. So I'll say when cat talks, it says meow. Okay, and now I'll execute this class, and I'll create one more class for dog, and when dog talks, it says woof. Okay, so basically what I'm trying to say is this is what is called as polymorphism. We can see that the same method talk is implemented in different way in different classes. So different way, different classes, same method. This is called as polymorphism. Okay, let me execute this. Now let me create an object of the class cat and give it the name as cat1. Okay, and when I say cat1 dot talk, so when I say cat dot talk, it says meow. Okay, let me define an object of the class dog and call it as dog1, and when I say dog dot talk, okay, I have to, so this is dog, so when I say dog dot talk, it says woof. So this is nothing but polymorphism. So we can observe that the method we are calling in both these classes are same, but the result is different because they are implemented in a different way. So that is all about the introduction to object-oriented programming concepts with Python.